Hello, welcome back to Reversing Game Shaders. Today I will show you Intel GPA, go through some vertex shader code, and do some experiments. The whole point of this exercise is to figure out what data BIA uses to draw static objects such as weapons. Since I partially reverse engineered the CRF format the game uses, I will start off with that knowledge in mind. Today I'm using Intel Graphics Performance Analyzer because it supports DirectX 9 and shader editing. Alright, so I'm going to load frame capture. Alright, as you can see, the normal pistol is not this size. I scaled it up and translated it to make this reversing a bit easier, and I also replaced the diffuse texture with something simpler. So I'm going to find the draw call that draws this pistol. Yep, that's the one. Here I can see its geometry. Let's draw it as normal. And GPA provides similar things to PIX. I can look at the API calls that led to this call, although I can't. So in GPA, in PIX, I was able to click on certain things to get more details, and GPA I can't. Some of this information is in tabs. So for example, the textures. Here's my diffuse texture. Here's the texture that's used for modifying normals. DirectX 9 state. The shaders, vertex shader, pixel shader, shader constants, vertex shader constants, pixel shader constants. So the first thing we're going to take a look is the vertex shader. That's what we'll be working with today. The first line tells us that it's a vertex shader model 3. Next line defines a constant 14. These sets of lines define what the inputs to this shader are, and we can match them to the vertex declaration that I saw in PIX. So V0 is the vertex position, which is of type float3. Blend weight V1 is a D3D color, and D3D color, the way it works in DirectX, it's supplied as a 0 to 255 value, so it's a byte, unsigned byte, and then it gets scaled to 0 to 1. This will come in important later since several of these are D3D color types. And then we have V2, which is the texture coordinates, and they're shorts. And we have another set of shorts, which I'm not sure how they're used. And then V4, D3D color type, is the normals. And then another D3D color, which I'm not sure what they are. And then after the inputs, we have the outputs. So all these values with O something are outputs. And their types don't necessarily have to match up to how they're actually used. So, everything beside position is text coord, but that's not actually how they're used. Alright, now that I know what the inputs are, I'm going to play around with the shader a little bit just to verify that what I think is true is true. So the first thing I'm going to look is the vertex positions and see if I can modify them. So if I look at V0 and I look where it's used, so this is the first instruction where it's used. Mat is multiply add, so it takes the vertex position, multiplies it with C14, and then adds C14, and these are swizzle operations. So this Z refers to this value, so it's replicated several times whenever it's multiplied with these values. So what I'm going to do is create a new constant, C15, and its x will be 0.5, y will be 0, z will be 1, w will be 0. And after I do this multiply add, I will do this multiply add, which will basically override whatever this instruction did. And as you can see here, I'm using C15x, which is 0.5. So what this will do, this will scale the model in x, y, and z direction by a half. So the model should shrink if indeed v0 is vertex positioned. So I'm going to hit apply. And look at that. The model was scaled down by half. Alright, so v0 are definitely vertex positions. After the vertex positions are copied into R1, we have to follow what's happening with R1. So in the next instructions, R1 is dot producted with C0, and the result is stored in R0.x. In the next instructions, R1 is dot producted with C2, R0, and stored in R0.z. And in the next instruction, R1 is dot producted with C1, and the result is stored in R0.y. Now these C0, 2, and 1 are constant registers, and we can see them in this constants tab under vertex shader and floats. So C0, C1, C2. And what's happening, what I think is happening in this set of instructions is that the vertex positions are transformed from object coordinate space to world view space, because this is typically how vertex matrix multiplication is implemented. And in the next set of instructions, R0 is also dot producted with some other constants, which GPA is telling me are zeros, so C3, C4, C5. GPA is telling me that these are zeros. However, Pix and NVIDIA Insider tell me that there are other values, so I think there might be a bug in GPA. I'm not sure. But my hunch is that these sets of operations on R0 are transforming the world view to perspective coordinate system, and then storing them in output 0, which the declaration tells us are positions. So we can try to verify that at least the output 0 are positions. And I'm going to do that by finding output x, and I'm going to overwrite output 0.x with something else. So I just kind of randomly picked two inputs, and I'm going to override this output. I'm going to hit apply. Oh, look at that. It's a completely different position now. Okay, so now I know that O0 are the output vertex positions. Alright, so I'm going to go ahead and just revert the shader back. So at least this output has been verified. The video is running a bit long, so I'm going to stop here. Next time, I will resume with experimenting on the vertex shader, and perhaps start looking into the pixel shader. Thanks for watching Reverse Engineering Game Shaders. Keep your powder dry.